Now we're going to look at a consumer surplus and a producer surplus. Let's say that X bar, P bar is a point that's on the price demand equation given by this. The consumer surplus for that price level, P bar, is given by this definite integral. We're going to take the demand equation, subtract that value of P bar, and we're going to integrate from 0 up to X bar. So X bar is our upper limit of integration. Now, what you're finding here, if you graph that price-demand equation, here's the graph of the price-demand equation. Notice the x-axis is the demand, x, and the y-axis is your price. Notice as the x gets larger here, the price is falling. It's getting smaller. So that's what that's what's happening with the price-demand. Is the higher the demand, the smaller the price will go. So now, what the consumer surplus is we're going to be checking at some certain level of price. So in this case, P bar is the price level that we're interested in. And that's just some value that is on this curve. So we've got this P bar here. We're going to look at that horizontal line. This is the horizontal line, P equal to that specific P bar value. Okay, so now what this consumer surplus is it's given us this area that's bound between the price-demand equation and that constant line, P equal P bar. And what that represents is for a given X in here, there were people that were willing to buy an item at a higher price. All the people in here, in this region here, up till the X bar, were willing to pay a higher price. There was a demand for a higher price, at a higher price. So those people, those consumers, are actually going to be saving money. This area here represents the savings by those consumers because they're not having to pay that higher price if they were willing to. They're getting to pay the P bar here. So P bar is the price that's set, and those consumers are saving money getting to pay it at that level. So this is called the consumer surplus, the savings by the consumers that were willing to pay a higher price for the items they were going to buy. So, okay, so let's say we're given this price-demand equation, which is a straight line. So if you graph this line, I see the y-intercept is at 200. If I found the x-intercept, it's going to actually hit the x-axis down here at 10,000. What I want to find first is I want to find for the price level of 120. That's that value that we're going to be interested in. So I'm going to draw that 120 in here. Here's P equal 120. That's P bar. This is a specific price. I want to find what the demand is for that price. So I'm going to take P bar, which is 120, and I'm going to take my price demand equation, which is 200 minus 0.02x, and I'm going to find where they intersect. So we're going to have 120 equal to 200 minus 0.02 x. So then I'm going to bring the 0.02x over here and move the 120 over and get 80. And then when I divide, I'm going to go ahead and multiply both sides by 100 here just to remove the decimal. So 2x is equal to 8,000, and so that means x is 4,000. That is the x bar. That's the demand that corresponds to the P bar price that we're set. So let's see, if this is 5,000, 4,000 here is where it's going to intersect. So I know that the graph of this price-demand equation is actually going to go through that point, 4,120. So that equation, I know it was crossing the x-axis here, looks like this. This is your price-demand equation. Okay, and then we've got our equation here for the P bar, which is 120. That's just a horizontal line, P equal to 120. Okay, so what we're looking for then is this is the consumer surplus. That's what the consumers that were willing to buy for a higher price are saving. So now to find that area, it's just the area between the two curves. So now the upper function there is the price-demand equation. So we're going to start with the 200 minus 0.02x, and we're going to subtract that constant equation, P equal to 120. Okay, and if you remember, the formula was d of x minus P bar, and we went from 0 to x bar. Well, you see the interval that we're going to be looking at is from 0 to 4,000. So this is our consumer surplus. Okay, so now simplifying this, we're going to have 80 minus 0.02x from 0 to 4,000. Find the antiderivative. We're going to have 80x minus 0.02x squared over 2, so 0.01x squared, and reevaluate it from 0 to 4,000. So putting in 4,000, we're going to have 80 times 4,000 minus 0.01 times 4,000 squared, and then minus what you get putting 0 into both, which is just going to be 0. So we're going to have 80 times 4,000, which will be 320,000. 4,000 squared is going to be 16 million, but times 0.01 is going to be 160,000. And so we're going to get 160,000. So if you think of this as just an area between the two functions, it's real simple integral to set up. You don't even have to memorize a formula. Okay, now the next one we're going to look at is called a producer's surplus. Now we're looking at the price-supply equation, and this X bar, P bar is just some point that's on that price-supply equation. So the producer's surplus, okay, we're going to be looking at a specific price level, whatever that P bar is, and we're going to be figuring out what savings are made by the producers that were willing to sell for a lower price, but now they're getting a higher price than what they were expecting. So P bar here is this fixed price that we're going to be interested in. So that's just the price that we're going to be looking at to investigate this producer surplus. The price supply equation here is going to be this function S of X. Okay. So now the more that what the producer surplus is representing is the gain by the producers who were willing to sell. They were going to sell some units here, whatever these units were, they were willing to sell them for a lower price. But they don't have to. They're actually getting to sell it for this P bar price instead. So that's money, that's savings by or extra money by the producers that are now getting to get a higher price for the items they were willing to sell. So what we're looking for here is the area between these two functions, and that represents that producer surplus. Okay, so we're given this producer surplus equation. It's a quadratic, so we know it's going to be a parabola going upward just based on what the equation is here. I don't have the vertex. If I want to find out where it is when x is 0, it's up at 15. So the price would be 15. And let's see, 55 is where I'm interested in. So let's see, 5, 10, 15, 20, 25, 30, 55. So here's the price level of 55 that we're going to be investigating. Okay. So now let's just say that the parabola was opening upward like this. And what we want to find is the area between this line, P equal to P bar, which is 55, and then this price-demand equation, or price-supply equation. The S of X, or P, equal 15 plus 0.1x plus 0.003x squared. And we're looking for this producer surplus. That's the extra money the producers are getting that we're willing to sell at a lower price. Okay, so to set this up, the first thing we need is figure out what the X is. What is the X here where that price-supply equation is intersecting with that 55 price level? So we're going to have 55 for the price, and we're going to look at this price-supply equation of 15 plus 0.1x plus 0.003x squared, and find their intersection. So we're finding X bar here. So we're going to have 55 equal to 15 plus 0.1x plus 0.003x squared. It's a quadratic, so I want everything on one side. So I'm going to have 0.003x squared plus 0.1x minus 40 equal to 0. And now, because I'm not going to be able to factor things with those decimals like that, I'm going to multiply through by 1,000 on both sides and get rid of all those decimals. I'm going to have 0 equal to 3x squared plus 100x minus 40,000. At least now I have a chance. So now this actually does factor. I'm going to have 3x and x. I need two things multiplied to be 40,000. I'm going to use 400 and 100. And then I need a plus for the largest one, and that'll be a minus. So I have that x is either minus 400 over 3, or x is 100, which of course x can't be a negative for what we're doing. So x is equal to 100. That's your x bar that corresponds to the p bar price. Okay, so now that gives us our limits of integration. So this is going to be 100. We're going to be integrating. That area falls between 0 and 100. So the integral, the producer's surplus, is going to be the integral from 0 to 100. Now in this graph, notice that that price, that constant function, is actually the higher function. So we're going to start with it minus the supply equation. 15 plus 0.1x plus 0.003x squared. Simplifying, we're going to have 40 minus 0.1x minus 0.003x squared. Integrating, we're going to have 40x minus 0.05x squared. If you do 0.1x squared over 2, it's going to be 0.05. And then minus 0.001x cubed. I'm just dividing the 0.003 by 3. And now integrating that, evaluating from 0 to 100, we'll put 100 in first, minus 0.05 times 100 squared, minus 0.001 times 100 cubed. And then when you put 0 in, it's going to be all zeros. Okay, we have 4,000. I'll have the decimal will take care of one of the hundreds, so I'm going to have minus 500. And then I'm going to have minus, let's see, the 100 cubed is going to give me 6 zeros. 3 of them are going to go away with the 0.001, so I'm going to have 3 zeros left, so minus 1,000. And that gives me 2,500. Okay? So that's the dollar savings by the producers because they were getting more than what they were willing to sell for.